All right, we go back um, to chapter 4. So it turns out we're going to do the second half of chapter 4, beginning in 4.4. But first, just what is this chapter? And then we're going to recap a little bit, um, some prereqs before we get into our first section. So it's systems of equations. What is a system of equations? Here's the definition: a set of equations which use the same variables. So we see that word system. And usually, when we use the word system, it's got a different meaning than this. Really, here, a system, we just mean a group or a set. At some point, somebody decided to call this set a system, and it stuck. So, just kind of where we are and why we're starting in 4.4. So, two equations, if you have two equations with two variables, usually x and y, those are the sort of things that we solve in elementary algebra. We are going to look almost exclusively at three equations here in intermediate algebra. That said, I'm sure it's been a little while. There were some of these, I believe, back in the review we did at the beginning of the semester. But we're gonna do a review problem together here before we get into 4.4. So we're gonna review a two equation system, and then we're going to dive in 4.4 to three equation systems, see a bunch of examples of those. Okay, before we even do that though, we're going to solve these. Our goal is always to solve the system. So what does that mean? What's the solution to the system? And here it is. I apologize for the shadows at this time of day. A solution to a system, values of the variables. Okay, well, that's not a surprise, but now there's more than one variable. Values of the variables that make every equation true. So if you've got two equations that will have two variables, we'll find the value of each one, and those two values would make both of those equations true. Of course, we're going to go on to three equations with three variables, x, y, and z, usually is how we call them. So we'll find the values of x, y, and z. Okay, well, let's get into a practice problem. For three equations, we solve by elimination. If you remember back to elementary algebra, um, typically students learn three solving techniques: elimination, substitution, and also graphing. We're not going to do any solving by graphing in this course. And I'm going to advise, don't use substitution when it comes to three equations. We're just going to stick to elimination. Turns out elimination is really allows for you to do the problem faster. But not only that, much fewer chances of making a small mistake. There's a lot of algebra and arithmetic that goes on in solving these. Okay, here's our example problem. Something that coming into Math 96, you should have seen in the past. We assume you've seen in the past. Of course, it's been some time. Here's two equations. 2x minus y equals 8, and x plus 3y equals 11. So we're going to practice this by elimination, because that's what we're going to do later as well. So what does that mean, elimination? And again, I apologize for the shadows. Hopefully you can still read this. The goal is to eliminate a variable by adding equations. What does that mean exactly? That's kind of, it's not quite clear. Eliminate a variable. For this example, we're going to multiply equation 1, that first equation, by 3. Each part gets multiplied by 3. And then we're going to add that equation with equation 2. When we do that, we'll have negative 3y plus 3y. If those add together, they're eliminated. Okay, let's actually go through those steps. Let me try and keep it on the screen if I can. Okay, I need to block this. So here I am executing these steps. Multiply equation 1 by 3. So I've got 3 times 2, 3 times negative 1, and 3 times 8. 6x minus 3y equals 24. Everything got multiplied by 3. Okay, then I'm going to add it to equation 2, and I don't need to change equation 2. I can just copy it, x plus 3y equals 11. Okay, and I like this writing underneath style. I'm just like doing addition of just numbers, right? Old school addition. Okay, what's going to happen is I'm going to add my x's, add my y's, going to copy my equal sign, and I'm going to add what's over here. And so here's what I'm going to get. 6x plus x is 7x. These are eliminated, so 0, I don't need to write that, equals, and I'll add here to get 35. Hey, what just happened? When y is gone, I've got 7x equals 35. Typically, we'd probably write it right next to each other. But just like that, I've eliminated y, and I can very easily solve for x, dividing both by 7, x equals 5. Okay, this is great. I know the value of x, but I'm not done. I'm halfway there. I got one of the variables. I still need to find the value of y. Okay, let me pull this back up a little bit. So at this point, we call this next move back substitution. So I'm going to back substitute this value of x into one of the original equations. I'm going to plug it in either to the x here and solve for y, or the x here and solve for y. I'm going to choose the first equation for really no other reason other than it's the first equation. So I'm going to take my value of x and plug it in right there. So I've got 2 times 5 minus y equals 8. And I can quickly solve this for y. 10 minus y equals 8. Hey, I can just see that y's got to equal 2, right? 10 minus 2. So right there, I've got the value of y. And this is the way I write my final answer. A lot of people are comfortable with just x equals 5, y equals 2, but the tradition when solving a system is to write it as if it's an ordered pair, like a point on a graph. There's still a very strong connection between systems of equations and graphing. So I'm going to write it as an xy point, right? 5 comma 2 inside the parentheses. There it is. There's my answer. Okay. Let's pause. Let's stop this video here just with that intro, because when we get into our first example in 4.4, these examples, when we get to 3 equations, they definitely take some time. So let's stop this one here with this practice problem, and I will see you guys in the next video.